Once again, this video is about refraction. This time, instead of having a rectangular Perspex block, we've got a semicircular Perspex block. And again, this time, we have the number of degrees, the angle. We can measure the angle at which the ray of light enters the Perspex block, and the angle at which the ray of light leaves the Perspex block. Now, if we set it up so it's on just central, that's right. Now, at the moment, it's entering along the normal, so it's going along at 0 degrees. It's going straight to the Perspex block and straight out again. If I change that angle of incidence, and I make that angle of incidence equal to 10 degrees, yeah, you can see that the angle of refraction, it comes straight through the Perspex block and is refracted at this point. The angle of refraction is very close to 20 degrees, probably about 18 degrees, something like that. If I move to 20 degrees, now it's over 30 degrees, about 32 degrees. If I move up to 30 degrees, should be able to see, let me straighten this up again. You should be able to see that it's somewhat over 50 degrees, the angle of refraction. So the bigger I make this angle of incidence here, the bigger the angle of refraction here. And it's bending, because it's leaving the Perspex block, it's moving away from the normal. See what happens when I make it 40 degrees. Now at 40 degrees, you can see not only is the refracted ray here, and you can also see it's dispersed. It's starting to change into the colours. It's bluer on this side and redder on this side here. We're starting to see a spectrum. But also you start to see quite a strong reflected ray inside. Now, let's move up to 50 degrees. And at 50 degrees, you can see there is no longer a refracted ray. No ray is leaving the glass block here. Yeah? It's all internally reflected. So all of the reflection takes place inside the Perspex block. That is called total internal reflection, and it's very, very useful. And it's all about having an angle here, an angle of incidence, big enough so that we only get a reflected ray. We don't get any ray refracted. That refracted ray will only occur if you are less than something called the critical angle. And in Perspex, it's around about 42 degrees. If I get this to about 42 degrees, let's pull it down to 40 again. If I move it to 40, you'll see that I'm getting a refracted ray. If I carry on going up, that refracted ray disappears and I get total internal reflection. If this is not calibrated enough here, really, it's only calibrated in 10 degrees, but this is somewhere in the region of 42 degrees, and that is the critical angle for Perspex.